In the previous three classes, we talked about the manual programming, okay, for the NC part programming using the G code and M code. And at the end of the at last class, we said there are some limitations of this type of programming, and this type of programming actually need more effort from the programmer or from human. It totally depends on the programmer, so the programmer need to do everything related to the part program, starting from reading the drawings, converting the drawings into some information or notes, then translate this information or note into G code and M code, then take all this code and enter into the MCU of the CNC machine. For that, people still, as we see in chapter 1, still do development in this field in order to simplify the programming of CNC machine, make it more automated, and make it more independent on human. Okay, for that there are we already mentioned four methods for part programming. The manual part programming, and the second method is the computer assisted part programming. And when we say computer assisted, here the programming or the development of the program will be shared between the computer and the human. So the human will do some task, or the programmer will do some task. The rest of the task will be done by automatically programmed tool. So this automatically programmed tool is a tool which is a computer based used to develop the program for CNC machine. The difference between the manual programming and the computer or automatic APT here, automatically programmed tools, is in the coding also itself. I mean, the APT here will not use the G code and M code. It will use more high level programming language, which is like, depends on some instructions which is written in English, and this instruction will be fed to the machine, and the machine or the machine MCU will translate it into the lower level programming language. So for the NC part programming, in the manual method, we said the human will, or the programmer will develop the program by using G code, M code, and other type of coding or other type of character. Here a little bit different in the aim or the objective is the same, is to develop a program to complete or to accomplish a task for the learning center or mailing center and so on. But in this case, a different, it's like if you have more than one programming language. Okay. So the sequence or flowchart of the developing of the program by using computer-assisted part programming here is divided, as we said, between two parts. One part is for programmer, the other part is for the computer or the automatic part programming. So the part for human here, the human or the programmer will define the part geometry, define the tool path, define or specify the functionalities like speed, feeds, and so on. These things which need to be calculated by programmer and need to be defined either, by programmer, or also can be extracted from the engineering drawing or from blueprint. After the human do this task, it will send the task to the APT. So the APT here will accomplish the task. He will do he will translate the program, then do arithmetic and cutter offset compensations that was required by the CNC machine, then editing phase, then post processor. So all the first three phases here, starting from the reading of the define of the geometry, define of the path, specify of the function, this will be done by the part programmers. The fourth task later on will be done by the computer or by the APT. Okay. Okay, so this is the sequence of activities actually. The sequence also should be followed. I mean, the first part will be done by the programmer. When the programmer finish the first part, then the task will be accomplished by the computer or by ABT. So this is the first part by the programmer that will be done. So the part programmer job here will be done first, which is like, the machining instruction here, which will be written like English like statement. As we said, it will not be the same as the G code and M code. In the case of the G code and code, we use the address, we use the number, we use some of preparatory functions, some of M codes, and so on to define some miscellaneous functions. But in the case of the computer assisted programmer, BART programming, human here, or the task will be a little bit different. The human will define some instruction with using English instruction. These English instructions will be, or English statement will be fed to the machine or to the ABT, the automatically part programmer. So this will convert it into from high level language into a lower level language that will be understood by the CNC machine. So the two main tasks here for the programmer will be the define of geometry and of the part. That means it's more to define the dimensions, coordinates, diameters, radius of circles, and so on. So this all related to the geometry. Then it's go for specify the tool path. So need to define the sequence of the tools, which will be done first. What task will need to be accomplished first? Is it the movement, the drilling, the milling? So this all will be defined by the part programmer. So for example, here we have, this is the geometry elements. You have the drawings, for example, even though this drawing is not clear, but it's a drawing with some dimension here. There are some dimensions and there are some holes with diameter or with radius and so on. Also, there is another dimension here for the outside. There is some dimension for the length, for the width, for the height, and so on. So all these represent the geometry part of the elements. In addition to the, we have also points. In addition to the dimensions, we have points. So for example, we start from this point, we move to this point, to that point, and so on. Depends on the points here. Points is a location that need to do something or need to carry out a task there. So for example, if we move from this point to that point, need to do a circle there, need to do another circle here, and so on. So this will define the points, will define the lines. These lines here, for example, linear lines. These lines need to be like circular interpolation and so on. So all these geometry elements will be defined. There are some circles. So here we have circle with this, at this coordinates, with this diameter or with this radius and so on at that center. So all these values will be defined by the programmer. So this will be the first task of the programmer before he send this information to the computer to accomplish the program. Also, there is the part here is to highlight the nodes, for example, or the nodes of movement. Like we see before, we have movement from B1 to B2 to B3 to B5. This related to the sequence. So how or what are the steps or the sequence need to be followed by the machine in order to accomplish the task. So for example, here we have N01, N02, N03, N04, N05, and so on. That means this will be the path or the sequence of the path to accomplish the task by the machines. So the two parts, which is the geometry and also the sequence, define the geometry and specify the tool path and operation sequence for the machines. So these two parts will be done by the programmer or by the human who work on developing this program for the CNC machine. After, when we define the geometry here, need to highlight some of the points. We need to define point, we need to define line, we need to define circles as we see here. points, line, circle. So when we define this part of the machine, we need to put some characters to describe. So if I have point, they make like B. So point one, B1, point two, B2, point three, B3. Okay. So this B4, for example, is a point with this coordinates at X coordinate, Y coordinate, and Z coordinate. I define the point, I define the point character here, which is B4. Then I define the point coordinates, which is X, Y, Z. I have a line, I need to use actually this P or N or C. These are the character will be used with the programming language here. It's not like G code. Okay. So in the G code, no need to define this is a point, this is a circle, this is a line. In G code, we just say this is a fast movement, this is a feed movement, this is the feed rate, this is the speed, and so on, using the G and M code. Here, no G and M code will be used. Only it's a totally different method to perform part programming for the CNC machine. Okay, so in this case, they will be you will see. I mean, they are using like P for point, L for line, C for circle, R for radius, and so on. So they use this letter, and they need they are going to link between this letter by using some English statements like go right, go left, go up, go down, and so on. It's like the high level language in the computer programming. Okay, so when they define the line, also they define the line is connect between P1 and B2, for example. When they define the circle, they need to define the circle center. Where is the center of the circle, for example? What is the point that need to be locate the circle, I mean the location of the circle. What is the radius of the circle? What is the so as a value if we need to define based on the radius, for example. We need to define as a diameter, so also the same, they are going to define parameters. So this is the tool path sequence, for example, here. So as we said, if we want to define the path or the sequence of operation, we are going to use some language, I mean some statement in language here, English language. So for example, go left, like this one, go left. So this one, turn to left into L2, go left for L2. Then tangent to circle one. I mean, they are going to use this letter that we defined before, like for the circle, for the point, and so on. They add some information using English statements to specify the instruction for the machine. So the machine will follow this instruction. When we send this information to the APT here, it will convert it into some of low-level language, so the machine can understand this example. I mean these instructions. So as you can see here, go to point 5 means move the tool to the point 5. So in I mean in the slide you can see this one is S. Just please correct this one. It's 5. Okay. So move the tool to point 5. Here the just this is the translation like last time when we have G00, we have the I mean the explanation what we mean by G00 is rapid traverse or rapid movement to these coordinates, for example. Okay, the same here, just we use jog to B5, move to the point B5, and so on. Actually, in our course, we are not going to cover, I mean, to focus on this type of programming, which is using the computer-assisted path program, or also even CAD/CAM. We only have in production at the end of this course. Our focus will be more on the G code, according to the CEO of the course. So our focus will be more on the manual part programming. Okay. So manual part programming, that means we are going to use the G code and M code in our program for the CNC machine. We are not going to use any of computer-assisted part programming systems. Okay. Then after that, for example, we need to define cutting speed, feed rate, also need to be specified by using similar statement for this one. I mean, like speed rate, SP, and so on. So they have some definitions for, I mean, based on the language that we use by the APT here. So then this all information that the programmer will develop will send it to the machine, I mean to the program, to the computer here, in order to make like interface to send the information from the programmer into the CNC machine. So I mean, according to this flowchart, after the programmer will do his part until this point, then it will send to input translation, arithmetic and Qatar offset compensation, aiding phase and post processor. So all these four tasks will be done by the by the automatically programmed tool. Okay. So these are the tasks that will be done by APT. Input translation, so result in output file. That means since we are dealing with a computer here, so all the information that will be saved in some file. So for example, this we call it P profile, for example. This for the main part or the main program profile. Then the second part, which is arithmetic and Qatar offset compensation, will result in output file. They call it Qatar location file. So they call it CL file. And all this file will be stored in the computer actually. Or it will be a result of the sending of information from the programmer to the APT. Okay, so we will have a profile here, file of the profile, and we have also data location file, which is CL file. Editing also, which is CL data here for machine commands that we already feed by using this language here, like to go left to L2, tangent to C1, and so on. All this will be feed also, will be stored in a file. They call it CL data here, machine commands. So this will be depends on the type of the machine tool. So in order to translate this one into the low level code or low level language of the machine, so there will be like interpreter to convert this information that feed by a high level language into a low level language to the machine. Okay, then the last will be post processing. So it's a separate computer program specified to connect to concern the tool. So after the do the all task this one, input translation, arithmetic and Qatar editing phase, they go to the post processor, and post processor here represent the last step by the computer before sending to the CNC tool or CNC machine. Okay, so that means the task will be shared between these two parts, and all this will be done before we send it to the CPU, or to MCU of the CNC machine. After we have the complete files for editing file, arithmetic file, translation file, and also we will be sent all to the computer or in the last step for the post processing. So output of post processing here is a G code program in addition to X, Y coordinate, S, F, M word, and so on. So the last step here, in the first part, as we said, the program in the manual part programmer the programmer will develop his code by using G code and M code because he's a programmer. So he developed this using the manually, then he enter it directly to the machine. But in the case of computer assisted here, all these the task of programmer will be written in different language. With such English statement, he write this code, he send it to the computer will generate this will interpret this code before sending it to the CNC machine, and the CNC machine here will receive it as a G code. So the same as in the case of the CAD and CAM. So in the CAD and CAM, the programmer will not write any code. He will only make drawings. He will enter coordinates. He will do drawings, 2D, 3D drawings, and so on. He will define all parameters. Then the software itself will generate the G code that will be sent to the CNC machine. Okay. In the manual part programming, no, the programmer who is going to develop G code. So our focus will be on the manual part programmer because we want to see how we can develop the G code for the CNC machine without the help of computer or without the help of also CAD and CAM softwares. So the post processing here is an interface between the APT and the machine tool. So machine tools here can be lathe machine, milling machine, turning machine, and so on. So this will be, I mean, the post-processing stage, which is, we show it here in the diagram. This one, it's like the interface between this part, which is of the computer or APT, this one of the APT part, and the machine which will be located in this area. So here we have the CNC machine. So here the program will, after we complete the program will be sent to the MCU of the CNC. So this is about the computer assisted part programming. So computer assisted part programming, how, for example, if you may be asked what is the difference or differentiate between computer assisted part programming and manual part programming. Okay, some example about this one, I mean, or provide some example how the computer assisted part programming work. What is the task of the computer or ABT, or what's the functionality of ABT in computer assisted part programming. So all these things will be related to, I mean, will be related to this part of the chapter, but you are not going to be asked to develop a program for computer assisted part programming. Okay, so you are not required to write such coding by using large instruction using the English statements. You will be asked to write such code which already I mean developed by using manual part programming. The third type of the part programming in CNC machine is the using CAD and CAM. CAD is computer, I mean computer aided design or computer aided manufacturing. So both of them, I mean, CAD was about, previously CAD was like a separate system, CAM is a separate system. I mean, both are represent like some phases of the development for the CNC, I mean, numerical control. Recently, they combine both parts, which is CAD and CAM. So previously CAD was more specific just to develop drawings, develop design, I mean engineering drawings, blueprint, and so on. So for example, if you like AutoCAD, some of the 2D and 3D software, just they used to make a design, drawings only. And programmer take these drawings, go to read, understand, convert this drawing into NC, I mean into part programming or G code. But recently, the software itself, which is, I mean, used for CAD, it also used for CAM. So they combine, I mean, like the one that the software that I share with you, either for the solid state, I mean, SolidWorks, or the Fusion 360 with the feature CAM and so on. All these type of software, they have the capability to do two parts of work, to design, I mean, to use to draw or to design the product by using engineering drawing, either 2D or 3D, then they convert or generate the G code from these drawings. You have drawings for square, you can generate a G code from this square. You have drawing for cubic, for a circle, for any work piece you want to do. You already have the drawings using 2D or 3D. Then these 2D or 3D drawings can be easily translated or converted into a G code. And this G code will be sent directly to the CNC machine to perform the task. Or this G code can be used to simulate the behavior of the CNC machine in a simulation environment without producing a real product, but it can show you some of the product which is like virtual product in the form of the solid product or solid object with the same design that you enter to the programs. Okay, so in this method here, in the CAD CAM, what's the difference between CAD CAM and computer assisted? In the computer assisted, the programmer still has some tasks to do. He developed the program which is like instructions. He defined the geometry, he defined the point, he defined the circles, he defined the line, and all this translated into some instruction. This instruction will feed to the APT. APT will generate the G code. But in the case of CAD/CAM programming, only the designer who will work. No need to be a programmer. I mean, in order to work with such part programming method, which is CAD/CAM, no need to be a good programmer. You should be a good designer. If you are a good designer, so you can make a good drawings or with the specific dimensions, with the specific or more uh, definition for the place of the holing, the place of the turning, the place of lathe, and so on. So after you create the object by using the 2D or 3D drawings, the software itself will generate the G code for you. So I mean, even you are not good in programming, still you can generate the G code by the help of this computer or computer software. So the computer here does most of the part programmer job. It's not like manual part programming where the programmer do all the job. Read the dimension, define the sequence, write the G code, write the M code, and so on. This is in the manual. In the computer assisted, also still need to do some instructions, still to define some geometry, and still need to define some sequence for operation. But here, no. Here just need to design the product, define the dimension, define the coordinates for the product, and so on. Then the computer or the software will generate the G code that will be sent to the either to the CNC machine or also can be simulated as a real using a virtual environment. So what are the CAD/CAM advantage here? Part program can be simulated offline. That means without connecting to the CNC machine to verify the accuracy. So I mean, when you perform the when you use the CAD/CAM systems, you can check how accurate is your design, how efficient is your design, how cost effective is your design, just before, because you are going to see how many material you need to use, what is the cost of this material. All this can be done using the CAD/CAM software. So then the time, the cost of the operation can be also determined by the CAD/CAM systems. Automatic tool selections. No need to define the code by yourself, go to select tool number one, go to select tool number two. No, the system will select the tool based on its or based on the drawings that already fell inside this system. Automatic optimization of the speed and feed rates. That means the system here or the CAD/CAM programming system will decide which is the good speed to accomplish this task, which is the good feed rate need to be selected. Since there is, as I told you before, this regarding the speed and feeds rate here, all they came for each CNC machine, it has a list of the parameter which is like rated values or the good value. This value is good to use with aluminum. This value is good to use with steel. This value is good to use with plastic. So they have the same some speeds, a good, I mean, definition of speeds or array of speeds and feed rate. So the computer aided, I mean, the CAD and CAM system here will be able to select which is the most efficient or the most optimal value for feed rate and speed to accomplish this task. What is the best material to be selected and so on. So all these represent the advantage of CAD/CAM over the previous the previous two methods of part programming. Also, immediate visual verification of the geometric elements. After you finish to create the design in the 2D and 3D, and you simulate the manufacturing part of this design, you are going to see output as a real product, real. I mean, it's a virtual product, but it's identical with the real product. So you can decide, is it okay, is it good or not? Should I do some modification to this dimension? Should I do some modification to this diameter of the circle? Should I do any dimension? Modification to the place of this part and so on. So after the simulation, you can see real product, so you can decide is it okay or not. So the geometry definition here using the CAD/CAM So how the, I mean, we said the most part in the or the main part for the or the main task of human or of I mean designer to do in the CAD/CAM is to create the drawings. Okay, later on the system will convert this drawing into program. So here the main task here in the computer graphic model, the designer will be the main player in this type of systems. Designer, that means the one who make the drawings. As I told you, it's not necessary to be a programmer. He can be a good designer, a good one who make drawings. Okay, he can define the drawings in the 2D, in the 3D. He can identify the place for geometry, the place of element, and so on. So this will be the main task of the designer. Then after they do the drawings here, the model will be stored in the database in order to perform NC operation. And I mean, after you usually such software or such system, the main when you want to create new thing, you need to create new project, for example. New project, then in this new project, you need to give a name for this project. You need to save it in a database or in on your hard disk or some of this product support the cloud operation. So you can save it in the cloud of the company that developed this software, for example. Then after you already define the geometry here, this geometry will be converted by using some of the package or libraries inside this software. So it will convert this software into a G code. I mean, it will convert the design. You have the drawings. You make the drawing. Then you select which is the machine that you want to use. It's like setting. It's like menu. In the menu, you go to the menu. You select. I want to use this. I want to print this drawing, for example, using this machine. I want to produce this product by using that machine first. Then I use the other machine. I mean, you need to program the sequence for operation for the machines. So then just the computer or the system, CAD/CAM system will perform the task. So here also for the geometry element, you need to use some symbols. I mean, when you define on the drawing, the same, because since you still need to have drawings, so you need to define such lines, circles, point. I mean, it's just labeling. So for labeling here, this labeling can be easy read by the others. I mean, you do not make the design for yourself. I mean, the designer will not do the drawing for himself to do. No, he will make the design, but this design should be understood by others in the team. Okay, so for that they have to use some standard form or standard character to define the drawings, lines, circle, and so on. Also the coordinate, the uh, the the flow of the points or the path of the machine. The toolpath generation here using the CAD/CAM. Toolpath means how the CNC machine tool will be used, or I mean, after we define the design, we make the design for our drawings. So the part here for I mean, to define the libraries, as I told you, there is libraries, there is some package for in the software. So how to include or how to utilize the existing library or package for this for the production line or for the product manufacturing. So this would be like the part for the programmer. So the designer do the design. Okay, he has a good information about the design. He do the design. He defines some labels and so on. Then want to send this product from the, I mean, in order to run the manufacturing part. So the programmer here his task will be only to like execute the program and decide which is the good library that we need to use, which is the good operation that we need to use, which is the good sequence that we need to perform, and so on. After that, if the programmer want to do, actually this software also, there is a capability to include some add-on libraries. Like if the programmer see, I mean the designer think this product cannot be produced because there is some missing libraries here in this software, or some or lacks of library, because not all software are same powerful to each other. I mean, there is some software more powerful. There are some software they support the open source. They have software they are not allowed for identification. So for some software, if there is a support for the open source, that means they allow the developer to include more libraries. So the developer here can develop their own libraries and include into the CAD/CAM system. But if this CAD/CAM system not support the open source, it's a closed source which is owned by a company and not allowed to any modification. So it will be difficult for the programmer to add any libraries to the system. All these things, either the design, the required path, the required library, the required package that need to be used for this for producing such part, will be included into one folder. So this folder represents a project, and this project will be labeled as a specific with specific name for this product. Okay, so later on they can use it like we see in the manual part programming. We highlight something, we call it the program number. So in the beginning of each program we have to define the program number, so this program number can be called by the programmer or by any other user for the machine later on. Same here, all the related information to this project, including the design, including the geometry, including the libraries, the package that will be used, the tools that will be used, and so on. All this will be included in the project. So later on, if you want to reproduce this product, or if you want to modify this product to a new product, to a better product, so you can use the same library, then I mean the same project, and you can do some modification. I mean, not good always you start from the beginning. So the toolpath here can be defined using the interactive graphic system. So the graphic system is more on the, as we say, the graphic systems like the layout or the GUI or graphic user interface, which is on the CAD/CAM system software, like we said, SolidWorks or Fusion 360, or also the feature cam and so on. Individual statement in ABT are entered. What is ABT here? We said this is the automatically part. I mean the automatically part that we use in the computer assisted system. So this the ABT here, and the cam here will provide the graphics display and will result in the command. This is how to convert the part of, I mean the graphic, or how the graphics or how the drawings will be converted into the G code. This is more on the part how the CAD/CAM design or graphics will be converted into the G code, and this G code will be fed to the machine. Here there is a more advanced approach for generating toolpaths are used, because we by using automatic software model. We said the CAD/CAM system will support the selection of the tool, will support the automatic selection of the tool, will support the I mean, it's no need to define what is the tool need to be used first, what is, because it used to optimize, it will optimize, as we said here, automatic, it has automatic tool selection, also automatic optimization of speed and feed rate. So automatic tool selection here will be done by some models or by some libraries or software, which is like a subroutine or a subprogram need to be executed by the machine here to provide what is the required parameter for each cycle. As we said previously, when we talk about the manual programming, we said there is some of the cycle or canned cycle which is used repeatedly, or it can be used directly in just one line code. Like we said, when we said G81, this do perform drilling. So in this one in the part manual part programming. In the case of the CAD and CAM, it has some module or software or libraries which help the CNC machine to select the suitable cycle and the suitable subroutines to perform the machine, I mean the tool selection, or to perform also the optimization of the different parameters to produce this product. An animated simulation can provide the validation purposes. As we said before, one of the advantage of the CAD/CAM system is it allow you to test the product, to see the product before you go for the real production. That means we can simulate this product, and the simulation will support animations. So this animation will help you to understand more about the feature of the expected product. So then you can decide, is it okay? We can go for the real product. If not okay, we need to do some modification in the design. So you go back to do some design modifications. So for the computer automated part programming here, it's like this one. So I mean, it to define, you do the design inside the software, and you define some geometry inside the design here. Then you perform some of the, or you define some of the operation which is related to the product itself. For example, this product need for drilling, this product need for facing and shoulder facing, this product need for facing tool, this product need for trading. I mean, this all operation related on lettering, this all operation related to what is the operation need to perform on this product to finish this product and to come out with the uh, final product. Actually, we are going to talk about this shoulder facing and lettering all in the chapter 6 later on. Okay, about the operation that we need to perform on this product. Mastercam here is the leading commercial CAD/CAM software. It's a type of software package, okay, for CNC part programming. So this package actually it can be I mean included as add-on package to the existing software, or also can be used as a separate package for CAD packaging here in order to convert the design into part programming or into G code. Okay, so the input for such package will be only part geometry, work-based orientation, type of operation like milling, cutting, and so on, cutting tools and definitions. The output will be address format program. So this package here, it's used to generate the G code, which is the word address format program. So I mean, like such software or such CAD or CAD/CAM software will utilize this Mastercam package in order to convert the design or the drawings into a real word address format of part programming that we learned before, which is the like the manual part programming using the G code and the M code. At the end, you can see all the output of either the first two, I mean, manual part programming or the computer-assisted programming, or also the CAD/CAM programming. The code that we send to the machine, it is the same. It is G code or M code, CNC code or CNC machine here working or either on G code or I mean G code and M code. But the difference here, the difference between these three methods, how we generate this code. Do we generate it manually by using a programmer, expert programmer? Do we generate it by using ABT in the help of the design in the program with the help of the programmer? Do we generate it using some of the CAD/CAM software, which is generate this code by the help of some of the existing package for generating G code? The last type of this of the part programming here is the manual data input or MDI. So manual data input here will be used. I mean, as we know, the CNC machine, it has computer attached to it, beside it, and with the keypad. So the programmer will manually enter the data or the geometry, the point, the action, the motion command, and so on, directly into the MCU of the CNC machine. I mean, in this case, the programmer does not need to write the program first, does not need to use a computer to assess, does not need to use computer, I mean CAD/CAM programming. Maybe this will be more useful when you develop a simple program. I mean like 5-line, 10-line programs. So as I think you already see in the video that I shared before, how the operation, I mean the operator of the CNC machine can just enter the program directly into the MCU without the help of any other extra devices, either computer, laptop, and so on. Okay. So simultaneous machine here with the next program is with, when we use the program, as we said before, we are going to save this program under specific name. Later on, after we finish, I mean, there is some flag for start the program, flag to end the program, code to end the program by using mcode and so on. So this program actually will be developed by using the keypad of or the keyboard of the MCU with the monitor or the display, LCD display beside the MCU. After that, this program can be saved under a specific name or specific number inside the MCU directly without the need. During this work, maybe you will be asked, you want to save this program, you want to save this block address, and so on. So by using the keypad beside the machine, it's and the LCD display here, you can perform or you can develop multiple programs and blocks, and this program block will be saved under one program name or program number, and this program number will be called later on to perform the same task. Okay, so the manual data input here, as I told you, is just entering directly. No need to use any of the previous 3 type of the system. So this is the 4th method to develop the G code for the CNC machine. And till here, I think we come to the end of this chapter. Okay,